Solving quadratic equations. We've been solving quadratic equations, and the first method we learned was graphing. Here I've graphed x squared plus 2x minus 8 equals 0, and by looking at the graph, I see the solutions are at negative 4 and 2. I could have also solved this quadratic equation by factoring. And I would have gotten the factors x plus 4 times x minus 2. And using the zero product property, I would solve for x and find my solutions to be negative 4 and 2, just like when I graphed. Another method to solve quadratic equations is by completing the square. Let's review solving quadratic equations by taking the square root of each side. In both equations, what do we notice about the trinomials? So in our first example, x squared plus 6x plus 9 equals 5. If we're not looking at the 5, if we just look at what's on the left-hand side, we see it's a perfect square. So that's how we're going to solve these. We're going to have convert the trinomial to a perfect square and then take the square root. That's why it's called completing the square. So if I take x squared, let's do it this way. X squared plus 6x plus 9 equals 5. And instead of writing this trinomial, I write it as a factored perfect square. X plus 3 squared is equal to 5. I can then take the square root of each side. The square root of x plus 3 squared is equal to the square root of 5. The square root of x plus 3 squared is just x plus 3. And the square root of 5 is going to be equal to plus or minus the square root of 5. I'm going to then subtract 3 to both sides, and my solution is negative 3 plus or minus the square root of 5. So if I put that in my calculator, negative 3 plus the square root of 5 is equal to negative 0.76. Negative 3 minus the square root of 5 is equal to negative 5.23. And what does that look like on my graph? So here on my graph, if I plug in my 0 as a negative 523, I can see that is my solution. And if I plug in negative 0.76 for my x, I can see that also is a 0. So that's how you solve by completing the square, instead of factoring or graphing. Okay, let's try the next one. So g squared minus 8g plus 16 equals 2. And I changed this all to x. All right, so g squared, this is on the left side is a perfect square. It's x minus 4 squared is equal to 2. I take the square root of both sides, and that leaves me x minus 4 is equal to plus or minus the square root of 2. I add 4 to both sides, and that's 4 plus the square root of 2, 4 minus the square root of 2. And when I graph it, I see those are the same solution as on my graph. So that's how you complete the square. This was easy because we already had a perfect square and just converted it from a trinomial to the perfect square binomial. So, but what if the trinomial is not a perfect square? We can make it one. And the way we do that is we subtract the current c from both sides, find half of the b and square it, and add the results to both sides of the equation. So what does that look like?
We got another way to solve it. Complete the square, baby, that's the way that I resolve it. Hang with me in my class and your grades will not diminish. It's a lesson by my boy, he will get you to the finish. Quadratic, can get your terms on high to low. Divide everything by 8. You know that is how I roll. See to the other side.
Alright, that's moving c to the other side.
Cause b and that square it adds to both sides.
So then he took b, divided it by 2, and squared it, and added whatever, and that made the perfect square here, and it also, and whatever we do on the left, we do on the right.
Perfect square, you just have to recognize this is simplified when you go where it lies. Yeah, stand solve, call it the quad solve. All I do is solve, I get it, and knock yourself a ball.
So we're going to solve the first one by completing the square. X squared minus 18x plus 5 equals negative 12. So we're going to move c to the other side, and that's going to give us x squared minus 18x minus 17 is equal to minus 17. Now we're going to cut b in half and square it to create our perfect square. So half of 18, negative 18, is negative 9. Squared is 81. So if we add 81 to the left, we got to add 81 to the right. And this, now we have completed the square. We have forced a perfect square so we can factor by completing this, so we can solve by completing the square. So we convert x squared minus 18x plus 18 into x minus 9 squared. Combine these like terms and get 64. Now I'm going to take the square root of both sides. X minus 9 is equal to plus or minus the square root of 64. X, and then now I'm going to add 9 to both sides. So x equals 9 plus 8, and x equals 9 minus 8. And my solutions are 17 and 1. And I can verify that on my graph. Y squared minus 19y plus 4 equals 70. So we moved c to the other side, and that gives us 66. We cut b in half and square it. So negative 19 divided by 2 is negative 9.5. Squared is 90.25. So I add 90.25, let's highlight that, 90.25 to both sides. Now I've made a perfect square on the left side. And that's y minus 9.5 squared. So it's always going to be your b in half. And then combine like terms. Take the square root. And then add 9.5 to both sides. And my answers are 22 and 3, and that's confirmed on my graphs.